I think we're live. I can't see it yet, but I think we're live. So welcome. We've got 1 minute left to go. I've got to do some quick sharing, but first I'm going to give you a clue. I'm Caroline from Bubbly Maths, presenting problems, presenting some great activities for people who are home educating, doing maths at home now and ongoing. Right, this is a clue. Ooh, excuse me. This is a clue as to what we're doing today. It's a brief glimpse of what we are doing today. Right, so we have one of these things. And I'm going to, here we go. Let me see. Okay. It's a triangle, but wait, it's not quite right. Something about this triangle. We must have that angle is super important. That angle there must be a right angle for today's activity. So I'm just going to adapt it. Great thing about balloons, the bits that you don't need, like this. Ooh. There you go. There we go. Where's the right angle? It's not there, and that's not a straight line, but that's, we just pretend it is. We pretend it's a rigid balloon that makes straight lines. There you go. That is a clue for what we're doing today. And yes, we can do this activity with balloons, but you have to be a bit careful with the flex. They're little bit flexible, so you have to be careful with that. Okay, and also the scale is going to be different, so we have to look at the scale. Right, now, live. Okay, I've got that. Now I've got to go and do all the sharing and caring, caring and sharing. In theory, I'm there, but in fact, I'm not. That's not it. Right. Okay. Well, that's not being very helpful at all. So let's have another go. Let's do this instead. Discussion. It'll be a discussion in that one. We're going to be able to find the live, because once we find the live, then we can share it, and then my job is done. Then I can just finish. No, okay, first I'll do the live and then I'll finish. Right, here we go. Share to a page. I'm sharing to the Bubbly Maths page. So I'm Caroline from Bubbly Maths, presenting these lives for AIMSEC and the Aiming High resources that were originally made for the teachers that attend the AIMSEC courses, AIMSEC professional development courses in South Africa, and now it's the whole of Africa. And now these problems these resources are useful anywhere in the world. They're great mathematical resources. They've just been written so that you can use everyday objects. You don't have to have special equipment apart from a ruler, a compass, a pencil, a protractor, that sort of thing. And then the last thing I'm going to do is start a watch party. And if I do it that way, then hopefully I can share on my timeline. That's what I want to do. I've done it wrong before. I clicked on the other one and it shares it in the group. Well, what's the point of sharing it in the group? We're already in the group. Silly me. Right, start, show all. Oh, don't want to show all. Don't know what that's all about. And start. So that's the watch party started. Yay. So today's activity is called Doesn't Add Up. And we're going to find out why. Today's activity is all about problem solving. It's all about perseverance and determination and finding a way to get through and sort it. So what we're going to do is go straight to it. What we need is a ruler, ideally some colored pencils, a normal pencil, and if you've got it, square paper. If you don't, you do need to do right angles with this one, as I indicated before. So if you have, actually just thinking about it, if you've just got normal lined paper, you'd still be able to do it. If you don't have square paper, I'll just get some normal lined paper and show you a way of doing it on normal lined paper. So I'm going to start with square paper. And this is, you have to be fairly accurate. So this activity, by the way, is aimed at 7 to 18-year-olds, and if you download the resource pack that you can see there, then what you, sorry, I'm seeing myself recorded. Never mind. It's bizarre. This is, hi Boaz. Hello. No bubbles today, Boaz. Just balloons. Tommy. But Boaz is the most amazing bubble. If you want to put a link to one of your things, Boaz, please do, for people to go and go to YouTube or something. You are so welcome to put a link just for the joy of it. And then I'll or if you can find the maths, or oops, I found the maths on it. You're so welcome to do that in the anywhere you like. Just share your links. You're amazing. Okay, so right, that's completely distracted me, seeing the most amazing people show up on my popping into these lives. Right, so what I'm going to do is so I was saying that it's perseverance and determination are absolutely essential. These are life skills, and it's diagnostics. We're diagnosing, just like you diagnose if your car won't start or your family car won't start. If you diagnose if your bicycle doesn't work, finding a leak in the tire, in the rubber. If you are coding, you have to find, if there's bugs in your code, you have to find them, work out where the errors are. If you made a recipe, if you baked a cake and it doesn't rise, you've got to work out why. All of these things, these are life skills, and the better you get at them, this is what we're doing in schools. We're training to be really good at solving real life problems when we're adults. And today's real life problem just happens to be about triangles and trapezia, or as Americans call them, trapezoids. And so it's the one with the two parallel lines, okay, whatever you call it. Now I'm just going to find a way to put on the visualizer. I can do this. I can do this. I really can. I really, really can. Here we go. I can do this. I can do it. I can do it. Yes. Okay. So we have the visualizer. I'm just going to make sure I get my numbers right. So on the resource, you have all the numbers. Now it's super important that these, I'm going to make this square, super important that it's all right angles. So it's much easier if you can use square paper. If you can't use square paper, then you can use lined paper. And the way you can make sure it's lined, it's 90 degrees, is measure from, just in this case, this doesn't go all the way to the edge. So just extend the edge all the way to the edge. And then you know that there is a right angle. That is a nice, it's a right angle or 90 degrees. And then you can, now what I would do in this case is I would actually measure the distance between these lines, which is 8 millimeters. And then every 8 millimeters is 1 block. So for this one, it's, the square is 8 wide, so I would go, that would be what I would do if I was using lined paper. I go there, and then each of those lines goes across, and I'd actually draw in the squares is what I do. I'd make the squared paper for this activity. That is actually would be extremely useful to do. And so then we've got, that's, oh, it's 8. Hello. I'm like, how many wide is it? It's a square. So that it goes down to here, make that line down, and then draw the 8. I'm just helping those that don't have square paper at home. If you don't, I'm not doing this. Hopefully I'm lining those up well, and then line them up super well. Okay, I can't look over the top because of the visualizer, and then mark them, and then you can do the activity using those squares. Right, we do have squares here, so these are much better than any I could possibly draw. So what we're doing is we're drawing this shape here. So we've got, I'll mark out that's my proper pencil. Okay, I'll mark out the, oh look, if I put it here, you can still see it. That's good. So we've got 5, 3. I'm going to go here. 1, 2, 3, 5. I'm doing it upside down, so hopefully I got it about right. That wants to be a bit lower, and then 3. And then 8. I'll leave that in a minute. I'll mark this out first. So we've got, I'm going to go 8 down here. I wonder if those are centimeters. Oh, yay, they are centimeters. I love it when these are beautiful square centimeters. Fantastic. So we've got 8 centimeters that way. And if you're in the States, then it will be probably 1/4 of an inch. And then we've got 8. If we mark it out, that'll. So one of my favorite party tricks is to just make mistakes. I'm always making silly mistakes, and that's okay. It's just how it is. That's the way my brain works. I suppose in an ideal world, I wouldn't, but then my life wouldn't be so interesting. And one of the things I've had to learn is how to love myself and not get upset with myself and call myself stupid and things like that. Despite the fact that I do make silly mistakes, and that's okay. So we're doing 1 across here. If you can see what we've got there, I'm going to turn it upside down so you can see it on there, that way, and that way it doesn't, my arm doesn't move it. So we're doing 1 across here, and then we're going down there. And I'll just color that one in basically. And then we've got going up, let's get this right. Going up here, we're going to go across, across 3. I've already got that marked on there. Across 3, 1, 2, 3. And then this one is going 1, 2, 3, 4, 5. So we're going down to there. And then close that off. And then we've got, I guess we'll do orange on this one. So that we've got the red and the orange, you have a bit of contrast down there on the triangles. I'm going to color this in. I'm going to color it in just with stripes. If you can color it in as much as you like, as thoroughly as you like, I'm just going to color this in with stripes. Now I've done that there, but that line wants to be, when you cut, wants to go direct from here to there. I forgot to say you do need your scissors. I forgot to say that. The reason I'm drawing that in is just so that we have the triangles pointed out. So now I'm going to color it in. I'm just going to use lines like that so that you know that's a green triangle, that's a red triangle. You color in properly, by all means. You can use different colored paper, but well, you can't really use different colored paper because you have to cut it out of one square. So come to think of it, that was just silly. Although you could be super accurate. If you're super accurate, now that wants to go, that's going to go all the way, whoopsie, to that line, and that's orange. Okay. Now, I'm going to cut this out. So that's a 5. I'm going to put all the numbers on there. So that's a 5, that's a 5, that's a 3, and that's 5 plus 3 is 8. Okay. And I'm going to cut them out. Should we take a picture of that? Let's take a picture of that so that we have it. There we go. Maybe a square picture. Since it's a square. There we are. Now, I'm going to cut that out. Now, you do have to be super careful here. This is important. The larger scale you make this, the easier it is to solve the mystery. But you are being presented with a mystery, and it is up to you to solve it. And if anybody does know the answer, then please keep it to yourself and do further investigations. If you can look further into the resource, and there's other things you can do later on in the resource. If you know the answer, it doesn't help. It interferes with other people's learnings if you know the answer. So if the first thing that happens in a classroom is that somebody calls out the answer, whether the answer is right or wrong, especially if two people say the same thing, then the research indicates that everybody else just stops thinking and they just go with, especially if three people say the same thing, then there's like real power behind what they've said. And that's, so you really do everybody a favor. If you know the answer, keep it to yourself. Obviously, if you're doing a test, then answer it. But if it's, right, I'm going to go on the red line because the red line was the one that literally went between the two vertices. Super important that this line is straight. And the same here, the blue one was the one that joined the vertices. You want to go between those two vertices, and super accurate and super straight. Right, so now we have a jigsaw. You've made that, so you can, if you keep that for later, if you've got any younger learners in the house, or make more of these, you've got a jigsaw. So now that we've undone the puzzle, the next thing we can do is, actually, can we make, without looking, make that square again? So if we can actually make these into a square again. And then the next thing we're going to do is, and for this you can look, we're going to make it into, and I'm going to put this back onto the square paper. We're going to make a rectangle. So we've got one trapezium. That's it, one trapezium there. So that's 5 and 3. Then we've got a triangle. Let's get the right one there, that one. We've got 8, 5 and 3 and 8. And then we've got, okay, they're following that. And then we've got another triangle. Okay, so we've made a rectangle, and the rectangle is 5, whoopsie, there you go, by 5 that way, and then we've got 5 here and 8 here, which makes a total of 13. So we want, if we want to work out the area, how many squares there are in there, we just multiply 5 squares by 8 plus 5 by 18 square by 13 squares. If you don't know how to do 5 by 13, you can do 5 by 8 and add it to 5 by 5. You can see the amount of squares. Okay, so 5 by 8 is 40 squares there. 5 by 5 is 25 squares there. Get it the right way around. I'm doing it backwards. Okay. Now, so that's a total of 40 plus 25 squares. There's 5 times 8 there, 5 times 5 there, 25. So that's 65 squares in all. I'm saying 65 squares because we've got primary here that might not know about area. If you know about area, you know the area of that rectangle is 5 by 13, which is 65. And now going back down to this one, the square was 8 by 8. And 8 eighths are 64. So there were 64 squares in there. But wait, we've just cut up those pieces from that square. Wait a minute. What's going on here? I think I'm going to darken that print a bit. Make it a bit darker so you can see. 65 there. Oh, is that out of focus? Is that the problem? Ah, is that better? Here we go. 65 there. 25 there. 40. And then we've got 8 times 8 there, which equals 64. We've used the same shapes. We've cut those shapes out of there and put them in here to make that. And so your task is to, let me just get myself back on the screen. Stop share. Here we go. Yay. Your task is to solve the mystery. How can you have the same shapes, making an area of 64 if they're a square and 65 if they're a rectangle? There is an answer. It's not magic. There is an answer, and it's up to you to be a detective and work it out. Now, what are we going to do? What little tips? You must draw the pieces accurately. They've got to be, using squared paper, be very careful with those right angles. You're not going to solve the mystery if those pieces are not accurate. So go ahead and make the arrangement, make both arrangements with the 4 pieces. We can make a second square if you want, so that you can compare them. So you've got the 2 side by side, and look very carefully. See if you can explain what's happened now, and then you can make your own similar problem. A suggestion dimensions is 4, 7, and 11. And instead of 3, 5, and 8, use 4, 7, 11. And what happens there is the area is 121 versus 126 square units. Okay, and so draw those and make the 2 arrangements. Now, what we're doing here is we're looking for an explanation. Think about what assumptions you're making. Now, that is huge in life. So many problems are caused in this world due to making assumptions, as in, oh, I assumed that we were meeting. That actually happened to me. I was in Tanzania, and I was meeting the guy that's going to take me up Mount Kilimanjaro. Take me up, well, yeah, guide me up, drag me up. Last time he did it, he had to literally put his forehead to mine and just say, super strong, super powerful, to help get me to the top. He's taken me again. That was for my 50th, for my 60th. And both times I'm raising money for AIMSEC, the source of all these wonderful resources. So yes, you will be hearing about my Mount Kilimanjaro climb. And yes, I will be doing a fundraiser. So, and if you want to help with that, just let me know, contact me if that sounds interesting. And it will also be, we're making a mass resource at the same time as we're doing that. And we'll be training teachers, doing some courses while we're there as well in maths. So it's all, yes, that's just, the point is, I met him there earlier this year, just before lockdown. And he said, well, I'll be at the airport. I'll be at the airport at such a time. So we get to the airport and sending him messages. Where are you? He's not here. It's not like him to be late. And he's like, well, I'm at the airport. I'm like, well, I'm at this, I'm in this place and that place. And he goes, are you in Arusha airport? I'm like, no, I'm at Kilimanjaro airport. Oh, I hadn't said. He said, what's the airport? And I'd said, yeah, the airport. I wasn't aware there was more than one airport. We both made an assumption, and fortunately, he was in a position where he could actually come and join us. Didn't miss seeing him because I had a flight to catch. But yeah, assumptions. Think about all the times assumptions get you into trouble. So have you made assumptions now? And when you make an assumption, especially in maths or science, you state it. You say, my assumption is this. Be conscious of your assumption and state it. Say, right, based on the assumption that, and then you can look back and go, well, I'm assuming that. Well, what if you make a different assumption? Assume different things. And then you can be really systematic and analytical about your solutions. And so, and it's not about the answer. It's not about finding the right answer. It's about doing the detective work. It's about perseverance and determination and looking carefully and being aware. It's not about not making assumptions. It's being aware of the assumptions that you make and helping that guide. So you can do, once you figure it out, you can do it as a social media challenge to your friends, which you can use the pictures. There's a little meme that's on the AIMSEC Facebook page that you can use to share with your friends as well. Now, Grown-ups, if you're there, or older learners, don't explain it. There are some clues in the resource pack that you can give one at a time, but first of all, have a really good go at it. You'll learn so much just from an experience, so much from just having a really good go. Perseverance, determination. I would suggest don't just keep looking at it. If you haven't solved it, look at it over the weekend and then maybe look at the solution on Monday. But don't look at the solution. Get someone to reveal it to you one line at a time. There are 4 clues. So one clue at a time and see if that clue reveals it. And then, but don't do it yet. Leave it till Monday. And then for lower secondary, so that's for 11 to 14-year-olds, the questions you're going to ask yourself is, what do you know about the areas of the squares? What do you know about the areas of the rectangles? What do you know about areas of triangles? What do you know about areas of trapezia? Crikey, it's a lot of what do you knows. So you're looking at what you're using your knowledge to help you get to the root of the problem, the mystery, solve the mystery. And and here's a question: do you believe that a shape can change its area when it's moved around? So I'll just take this one. If I move that around, does it change its area? I've moved it around. Does it change its area? No, I have changed the shape of this other one. But and yes, it's a mystery. It's definitely a mystery. And here's a kicker. What makes a line straight? What is the definition of a straight line? Straight line. Okay. And then going on to the next level for 14 to 18-year-olds, look at gradients. What do you know about gradients? Can you use the knowledge of gradients to help solve this problem? And then there's an activity for, it's looking at the gradients for 16 to 18-year-olds. So what you're thinking mathematically, you're getting experience solving problems by thinking mathematically. And that is actually the key. This for science, for maths, and any problem in life. Diagnosing why cars doesn't start, finding your way on a map, and if you get lost, finding your way out, even working out if someone's confused, or you have a child who wants to communicate something to you, but you're not sure what they want to say because they might not be saying what they mean because they're distressed. By asking powerful questions and by being analytical and being a detective, you can actually get at what the real problem is. So even psychologists use this skill. And so be flexible, creative, innovative, apply the knowledge and skills that you know, and see how they help you to solve a problem, and develop perseverance and determination and the skill of checking details to check for the errors. Where is the error? Where is the glitch? Where is the code that is causing the problem? Details. It's all in the details. And then observation and visualization. So visualization is actually really important here. Visualization is important in so many areas. If you notice on all these activities, visualization comes in practically every single time. And so those are the skills you learn. If you're on YouTube, please do subscribe to our YouTube channels. These lives have been uploaded onto the Bubbly Maths YouTube channel and the Maths Toys YouTube channel, where you'll find the maths in games and the games in maths, have all of these. They will have, so far there's 7, but we're increasing it all the time. A resource, there will be eventually one video to go with every single resource on the Aiming High website to really help you get to grips with it. This is all aimed at home learning, and this will also help teachers in terms of just, again, getting to grips without having to do all the research and all the homework. Without, basically gives you a little bit of a shortcut to designing your lesson plan. So, and then if you like what you're seeing on this group, please do share and share the lives, and maybe share a comment, make a little post about it to let other people know about this group. And then you've got the AIMSEC Facebook page, I'll get it right in the end, And on there you have all these little memes, and they're being shared on the group as well, but you can go to the Facebook page and then it's much easier to locate them. Just for a moment of inspiration, that, oh, I just feel like doing something interesting. Or if you want to encourage your younger learners to do something interesting, just go there, have a look, and just have discussions about it and maybe solve some problems. And so thank you for coming. Let's have a look, see who has been visiting us. So Boaz, Tommy, hello Gina, James, hello, Aneta, hi from Denmark, and Marilyn Doyle, hello, welcome. Thank you for joining us. Now I do have to double check to see if anybody's made a comment on the Making Maths Fun group, because when I miss those out, young people get quite upset, because if they put straight on the page is refreshing, that could be good. Page is refreshing. Oh, here we are. Yes, no comments yet. So if you do have made a comment, I will check again later. The comments haven't shown up for me yet, so I can't answer them if they're not there yet. Sorry. So thank you very much for joining us. And the links I was talking about are in there's an introduction post announcement pinned to the top, and it's welcoming new members, and welcome if you are a new member. And it's also it gives you all the links to all the different things, as the YouTube and the Facebook page and the Bubbly Maths Facebook page and the Bubbly Maths website as well. Thank you very much, and I'll see you 10 o'clock. We'll have a session for early years. It's the same theme. So if you can prepare the same thing for early years, but maybe lots of them, so they can do the puzzles. Start with the 4, but give them the 4 and see if they can make a square. Just solve a puzzle and just play with the shapes. Okay, thank you. And then 8 o'clock tonight. Oh yes, 8 o'clock tonight, 8 o'clock tonight, tomorrow morning, 8 o'clock tomorrow night, and Sunday morning it's games. We're playing games. And then Sunday night, well, I'll introduce you to the resource that talks about the maths within the games. And then Monday morning, we'll look at the maths in the games with the primary and secondary. So children of all for ages 7 to 18. And then at 10 o'clock, as usual on Monday, we'll do I don't know what we'll do yet, but we'll do an activity for early years. Thank you for joining, and see you later. Yes, really, this time she really is going. Thank you. Bye.